Welcome to the classes of epidemiology. We had already talked about the analytic epidemiology. Please remember it is also part of the observational epidemiology. After descriptive epidemiology, we are dealing with analytical epidemiology, and there are two major types: descriptive epidemiology and analytic epidemiology. In analytic epidemiology, we had detailed about the case control studies. And then last time we talked about the basics of the cohort studies. We know that cohort is a group with some special characteristic and is being followed. For an example, a group of the persons who are smokers and they are followed for possibility of the lung cancer. Maybe till they happen to have a case of lung cancer, 5 years, 6 years, one may follow them. For the scientific study, such groups require a control group also. So if we say the study group as an exposure group, the another group will be known as a comparison group. So these two groups will be necessary. Now we are going into little detail about the cohort study. What should be the steps? Number one, of course, we need to select the subjects for the study. How to select the subjects? Naturally, those who have the exposure of a given factor which we want to study. Now, such a selection can be made from the general population also. Suppose we want to select smokers from a population of Ahmedabad city. Well, this can be done, but in that case, all those who are selected, suppose we are taking 500 smokers, they must represent the entire city of Ahmedabad because they need to represent all the smokers in Ahmedabad. It should not happen that 500 smokers in a given small area, they will not be representative of the general population. Because when we say population, the sample which is taken should also be representative of the population. Similarly, the second advantage of general population is you can select a similar type of the non-exposure or non-smokers from the population of Ahmedabad. Both these groups should ideally be selected on a randomized basis. Once you select them randomly, they represent the general population. And so far, so good. But how that is possible? Because what will happen? Say, compared to case control study, we are going to follow them up for a relatively good period, maybe 1 year, 2 years, 5 years. So they should better be stable in a particular area. If it is a defined area, this can be done in the general population also. Secondly, they should not migrate. Last time we told these factors. And one such study, Framingham study, was done in United Kingdom, UK, USA, and there the study was representative for a specific disease, heart diseases. Heart diseases are relatively common, and that's why for a relatively common condition, we may go for the general population as for the selection of the cohort or the exposure. But suppose it is not so common, then finding out such cases in the general population will be little difficult. And that's why what we do, we are going to the specific groups. In specific groups, the possibilities are better. For example, we select a group of the professional group, say doctors. The advantage here is they are easily accessible, they are a defined group, and more or less they are homogeneous in their characteristics, like say age, sex, occupation, marital status, educational status, etc. So one may select a professional group, maybe lawyers, maybe engineers, but they are easily contacted, they are easily followed up for a long period if it is wanted, if it is required to be done. So professional group is one of the select groups. Or say we can select people from those who have taken the LIC policies or insured persons. These people are also better located in a given locality. That should be the criteria. The only objective is they should be easily followed up. Can we take the college students who had studied, got entrance into the medical college in 2018? All these college group of the same batch. They can be, that's also a cohort. And if it is possible to follow them up, then there is nothing wrong. And on the contrary, they will be helpful because by and large, they will be in the same age group, will be homogeneous group, and can provide us information very positively. So such groups may be taken as exposure groups. Government employees, also they are stable by and large, and that's also possible. Now, second thing is here, if you just want to cite an example, doll study, which was performed on the lung cancer, so to identify whether the incidence of the lung cancer is more in the smokers or not. The investigators had taken the doctors working in the United Kingdom, UK, and they used the mailed questionnaire. They were sending them the questionnaire, asking them on the telephone as a follow up, and that study was a quite good study. So it was a professional group, and that can be done. Once the selection of the group is done, the second part is the exposure details, exposure groups. Those who are exposures or persons who are exposed. That is the third group. So first one was from general population. Second one from the professional or insured persons or alumni, like selected groups. And third possibility is exposed group. For example, suppose I want to study the effect of radiation. Where should I go? In general population, there will be hardly some persons who are exposed to that. But suppose I take the radiologist, where almost always they are at a chance of getting radiation. So such a radiation study may be taken on the radiologist or X-ray technicians, something like that. And there we may be using it in a better way. Industrial workers, when taken as a cohort group, they will be specifically important to find out something which is wrong in the industry, some chemicals which may be an exposure, some dust that may be an exposure, heat that they are exposed to the heat temperature. Such studies may be done in the industrial workers also. The cohort group in that case will be known as the persons who are exposed to the similar factor, occupational group. Huh? Once we have decided that the select group like this should be that is exposed group should be like that, then the second part is collecting the data. Collecting the data on, and we are interested here on what? Exposure. Whether this exposure leads to the outcome of a particular disease X or not. We have cited several examples, say smoking, whether it leads to lung cancer or not. Tobacco chewing, whether it leads to the oral cancer or not. That's why the exposure details will be collected much more. We are interested since how long that exposure is, every day how much exposure happens, and suppose that exposure happens, then since how long he is in the service or he is exposed to that particular chemical or radiation or whatever it is, exposure item which is under the study. And this can be done by meeting those persons who are selected. Once we select, say 500 persons from an industry, we selected. We can have personal interviews in details, that how, since how long in the service, what are the different transfers you had in the different departments, what was the rate of the exposure, since how long you are in this department, and how many frequently you are attending, are the shifts for 8 hours or more than that. All those details related to exposure. We want to identify the quantum of the exposure. Quantum can be what is the amount of exposure multiplied by since how long, the duration of the exposure. That will give us all the details about the exposed person's exposure. Such details have to be collected. The second part may be review the records. Sometimes the persons may not remember the details since how long they are in the service and since how long they are in particular department. A person who has studied in medical college and later on he worked in the radiology department. So we should go back to the records of his office records or records related to his medical records. All those records will also tell that since how long he has been exposed and what is the effect of the exposure during that period, provided the medical records are available. Third thing is we can go periodical examination. We can do the examination at the end of 1 month, 3 months, 6 months, or 1 year and find out What are the changes? Because in prospective study, in cohort study, we are going for a long period. Every time we check him up, and periodical examination will reveal certain factors that will be very important for the conclusion. And simultaneously, we can study the environment also. That the person who is working there, what are the changes in the environment, in the surroundings, where he works or where he lives. So, based on which particular factor we want to study, we will identify whether we should go for the personal interview, we should go for the medical records also, we should go for the environmental survey. Usually, all these things are combined so that the maximum information about the quantum of exposure is available to us. And why do we do collect this information? Because of two major questions to be answered. One, whether the individual who is selected in the exposure group is actually exposed or not. That will be clear. Two, if he is exposed, to what extent he is exposed. What is the level of the exposure? That is the second question which we are answering. And third, of course, we collect some data. What is the age? What is the sex? Marital status? What are the different habits? What is general hygiene? What are his history of the medical, like say, does he have diabetes or other conditions? Something like that. So all these personal and demographic variables will also be taken into details. Once the data is collected, naturally, we will have to compare with somebody. And that's why a selection group should also be selected based on who are the persons in the exposure group. Comparing all the variables of that exposure group, we will select another comparison group. Now, such a comparison group may be available from the population itself. Suppose I am taking 1000 persons from Ahmedabad. Similar 1000 persons may be available in the Ahmedabad city also, those who are not exposed to that. Or suppose I have taken 1000 persons who are smokers in Ahmedabad. Even among smokers, we can have subgroups like how many persons are smoking 2 packs of cigarette every day, how many are smoking 1 pack of cigarette every day. So, depending upon the level of exposure, the subgroups can be generated and they have a comparability because they are the similar persons. So, many a times the researchers do a trick. They go with the subgroup comparison. That's also possible. This is known as internal comparison. When internal comparison is not possible based on the age, sex, or exposure rates, when it's not possible, we need to go for the external comparison. And naturally, external comparison, you have studied in the case control study that all the factors which are present in the exposure group must be matched or compared in the non-exposure group. And so we can generate a second group for the comparison. And third one, suppose the groups are not identifiable and we have some difficulty. In that case, we can compare the general population. Suppose we have taken 500 smokers as exposure groups. In those smokers, the cancer rate has come out to be 70% of the people had cancer after 5 years. This is an example only. We will ask a question: what is the general occurrence rate, general incidence rate in the population, general population, apart from smokers or non-smokers? And we compare with that. The rate in the general population versus rate in our group which has been identified with the smokers. That is also possible. That can be done. And this is also useful most of the times. The fun here is, the most interesting thing here is, in cohort studies, we are finding the incidence rates. And can you recall that relative risk? Relative risk is equal to incidence in the exposed groups divided by incidence in the non-exposed group. If we find out that in the exposed persons and non-exposed persons, this will give us a relative risk. Relative risk is very important in a way that suppose they have the similar type of the risks, smokers and non-smokers, then it will come as RR is equal to 1. It shows that if there is 1% chance in the exposed, there is 1% chance in the non-exposed. It is almost equal. But if it is 2, it means that the exposed have double the chance. Double the chance means 100% more compared to the non-exposed person. So RR has its own value, and this can be done by the again by comparing in a way that what is expected, what rate is expected in the exposed group and what rate is expected in the comparison group. Ideally, but both the groups, if the variable, if the factor in the study is not responsible for the causation or association, it will be 1. But if it is more, then naturally there is a strong association towards causing the disease. There is a strong association. Okay, once we have done, there is a chance that even if we have groups, always at the end of the study, you can compare with the rates in the general population also. What are the morbidity rates for that given condition in the general population? What are the mortality rates? And but in general population, there is problem with the selection of the exposure group and other groups because there will be some difficulty in matching the factors. That's why we generally go with the select groups or specific professional group and so on. Once the data is collected, the very important thing which differs from the case control studies, we follow them up. Suppose we started the study in 2020, June 1st. Again, after 3 months, after 6 months, after one year, 2 years, we will follow both these groups, exposure group and comparison group. For what? For the possible outcome of the disease which is in the question. Give an example. Suppose we have taken exposure group, the smokers, and non-exposure group, non-smokers. We compare them after 6 months, whether any smoker or non-smoker has cancer lung or not. If it is so, then we go on identifying till our study period is over, say 5 years, 6 years, whatever it is. So follow up. But this follow up makes the cohort study most difficult. And that's why there are several steps. One, we can go for possibly we can go move with the periodic medical checkup, number 1. This is the best and we must do that. Or review the records, number 2. Or routine surveillance, which can be done on the death records, what is happening outside, what is happening amongst the selected groups. And the doctors in the UK were questioned by mail. Say mail questionnaire was sent to them, they were sending the replies, they were telephonically contacted that how you are doing that, and these things do help in follow-up. Better if you do everything, but as we had told last time, several issues come up. Some persons may die, some persons may migrate, some persons may leave the study because of one reason or the other, or they are transferred. In those cases, we should, starting from the study, we should decide that how we will remove or reduce the level of this attrition. Attrition means leaving the study. We should have a plan for that. Once the data has been collected, the analysis is taken up, then what are the measure indicators which can be identified by analysis? Number 1 is known as incidence rates of the outcome in the exposed and non-exposed, which will be A upon A plus B, C upon C plus D. If you look at that 2 by 2 table, and naturally probability when less than 0.01, it is significant. That means out of 100, only 1% is the chance that this is only by chance. Otherwise, there has to be some reason for that. It shows the strong association. Strong association. Generally accepted probability is P is less than 0.05. If 5 times out of 100, then it is considered to be strong or less than that. Second is RR risk as a relative risk, which we have tried to estimate. Incidence in exposed divided by incidence in the non-exposed. Incidence rates have been taken. Relative risk is also calculated. And then attributable risk is a new term. Attributable risk means AR. AR means how much is the contribution of this particular factor, which is known as exposure, in causing that particular disease. Clearly, how much is the contribution of smoking two packs of cigarette a week or two packs cigarette a day to the causation of carcinoma lung, or chewing tobacco 3 packs in a day for 1 year will cause the oral mucosa cancer. So that risk calculation, attributable risk, and it is identified that incidence in the exposed persons minus incidence in the non-exposed person. Naturally, non-exposed persons are expected to have less incidence divided by incidence in the exposed persons. So this will clearly tell you that this is the contribution of this given factor. Can you realize? Because if the incidence in the exposed persons and non-exposed persons is equal, then there is no fun. But suppose it is 10 minus 1, naturally the AR will be very high. And that talks that that particular risk factor is very, very responsible for causing the given condition. Last is population attributable risk, or PAR, population attributable risk, where incidence of that disease in the population minus incidence of that disease in the non-exposed persons. See, generally in the population, so cancer of the lung must be happening. So what is the incidence every year? Minus those who are non-exposed, what is the incidence? Ideally, suppose incidence of the exposed will be 5. In non-exposed, it is expected to be 2, 1 or 0. That is expectation. And if we find out that that suggests the role of the contributing factor, role of the association of the exposure. It's really interesting. If you go into those details, gradually the cohort study will identify all the individuals who are either terminating into a particular disease conditions which we are expecting, and then we have a real idea that compared to the non-exposed group, how much difficult or how much dangerous is the exposure group where the exposure is there. Our examples continue to be like, say, the smokers will have definitely much more exposure and to the carcinogen, and will lead to the carcinoma of lung compared to the non-smokers as far as the cancer lung is concerned. So this is how we move ahead. But then there are again different advantages, disadvantages, and calculations related to the cohort study, which we will be studying next time. Okay, thank you. Bye.